Warframe has these items that you can collect in-game known as Ephemera. An ephemera is basically a particle system, or it's an effect that you add to your character, and it is based on your character's body structure. It is parented to the skeleton emitted from basically the character itself. All of these ephemera, in theory, are rather simple to make. They just require a basic understanding of spawn locations regarding a static mesh or a skeletal mesh within Unreal Engine's Niagara system. Within Unreal Engine, we've started a new third-person project. The first thing we're going to do is we're going to open the blueprint for our third-person character. This is the third-person event graph, which opens by default. We're going to go to the viewport because this is the list on the left of all the components that make up this one asset. Make a new folder, name it VFX, go into it, right-click, create new Niagara system. On the top right here, we click on empty, we create, and we're going to name this Warframe_Ephemera or whatever you desire. First things first, we are going to sort out the behavior of this ephemera before we sort out the visuals of it. There are two ways that these behaviors can behave. We can have particles spawned at a moment in time, and from that point onwards, they are not affected by the movement of the object, or in this case, our skeletal mesh, our character, or alternatively, we can throw them into update, in which case they will move along with whatever they are parented to. So for example, if we wanted a magical sigil that moves in local space with the character's arm, we would place it into update. In this case, we want them to just spawn, so we're going to go to particle spawn and we're going to type in skeletal mesh location. Now that we're in the skeletal mesh component, we're going to go back to our blueprint and we're going to find character mesh. By clicking on this object, we can find it here, and we can find it in the content browser. Back in here, we can drag this into preview mesh and default mesh, since in our case, both of these are the same thing. Source mode at this stage we leave as default, and now in order to see what we've done under emitter update, we're just going to add a spawn rate. And since it's Warframe, we're going to set this to 10,000. And as you can see, everything is working as intended. We are going to set the lifetime range to significantly lower than this, perhaps something between 0.1 and 0.5. And we're going to lower the size of these sprites so that they don't take up the entire screen. And now you can see that they are spawning along the skeleton locations. We don't want this, so what we're going to do is we're going to sample the triangles of the surface. Once switching to triangles, you will notice that everything is snapped to the single vert right at the bottom by the root bone. We're going to scroll up in our component and click Fix Now to grant this component CPU access. And now all of the particles will spawn along the mesh. This is enough to be a relatively compelling or at least functional effect, and all we need to do to make this work is drag and drop the effect into our blueprint, and it just works. Compile the blueprint, play the game, and now we already have a particle system that is parented to our character. Functionally, we're done. But function is often nothing without form. This is where some art direction comes in. We're going to create a new shader for the sprites, and we're going to add our own flipbook just to make this more interesting. The visual that I'm going for right now is fire, so that's what we're going to create. Matte_fire. We want to have as much color control over this as possible, so we switch default lit to unlit, opaque to alpha composite, and the surface is the same. Now we're going to drag in a sprite sheet of our choice, plug the R into emissive color, and also into opacity, so that we have this. Because we want control over the variation, we are adding a flipbook node, which we are going to randomize. Add a parameter node, set this to 2, since this is a 2x2 sprite sheet. We're going to add a dynamic parameter over here, plug parameter 1 into animation phase, the UVs into the texture UVs. Back in the dynamic parameter, we're going to change the name at the top to phase. And what we're going to do with this is randomize this between 0 and 1 in our Niagara system. Because this is alpha composite right at the end before we compile the shader itself, we multiply the final color, the emissive color, by the opacity one final time. Here we're going to add a particle color, throw this into emission color, we're going to throw this into opacity. We don't want this to clip through our object, so we're going to add a depth fade, which fades this away from any surface. Hold M and left click for multiply. R into there, we're going to multiply this now by our alpha, plug that into opacity. We're going to multiply this by our particle color, and then multiply that finally by our opacity. So you have something that looks like this. This can now be fully controlled within our Niagara system, and it is basically 100% finished. Replace our default sprite material with this, and you will notice that this does not look particularly good, and that's because we haven't changed any of the parameters. Under particle update, click plus, dynamic material parameter, turn everything off, and switch phase from default to random range float. And this has now created variation. Under initialize particle, let's make these a little bit more interesting. We're going to go from a minimum size of 1 to a maximum size of 15, and the rotation we're going to set to random. What we can do now under update to add more visual interest is scale sprite size by speed. What this is going to do is stretch the sprite along the axis that it's moving. We don't want this to widen at all as it goes faster, so we're switching this back to 1, and we're making the maximum stretch in this direction 3. This will not work immediately, however, because there are no forces acting upon this. So under particle update, we're going to add a curl noise force, set the strength to something like 1000, just so we can see it more easily, and set the noise frequency to something like 30. Now you can already see that this is a constant noise that exists in world space, as in it is a vector field that basically just pushes particles in different directions based on where it exists. And we're going to move this by selecting pan noise field, and then we select something very slow along the global z-axis. So now over time, our noise is going to move in different directions. What we can do now, just to make things more interesting, is curl noise force, Control-C, Control-V to duplicate it. We're going to make this one slightly weaker, about approximately 900, but we're going to make the frequency significantly higher, and pan it in the opposite direction for added visual interest. Let's bring this down to like maybe 500. This is already too much velocity for this, but in terms of demonstrating our purpose, this works fine. Under sprite renderer, we're going to align this to velocity. So now the sprites are pointing in the direction that they're flowing, and we're going to add collision. This will generally depend on the performance hit you are allowed based on your VFX budget to approach, but in our case, we don't have a budget, so we're just going to stick with ray-traced collisions. This means that these particles are going to collide with everything in the world and actually behave like real particles would. Visually, these are very boring, so in particle update, we're going to type in scale color. Switch from RGB and alpha separately to RGBA color curve, and we're going to fade these in very quickly at the beginning. They're going to keep their full opacity all the way towards the end, at which point they will fade out once again. We're going to begin with them being very hot, very bright. We're going to give it an emissive value of 5, get rid of the stop entirely because it's actually messing with it significantly, and then over time, the fire will burn out until eventually it just fades away. In order for this to be fully visually interesting, we're going to duplicate this and change the behaviors of the two of these. We disable the second one, and in the first one, we're going to keep the rate of change of these, but we are also going to bring down the amount to approximately 3000 and bring down the size significantly to be values between 0.1 and I'd say around 7. Under scale color, we're going to keep these brighter and hotter for slightly longer, but we're going to fade them away more quickly towards the end of their lifespans. These will now behave as embers. Under scale sprite size by speed, we're going to lower the velocity threshold to about 100 so that they stretch, and we're going to lower minimum x to 0.1, maximum x to 0.4, minimum y to 0.5, and maximum y to about 2. And now we have very erratic embers. Disable this one and enable the second one, or keep both enabled and enable solo by clicking on isolation tab over here. And we're going to lower the amount of curl noise force by about half. At its most basic level, this is already functional. From this point on, I'm just going to tweak a few settings, and then we're going to see what we get at the end of it. That's already good. And now we're going to add an entirely new system. Add emitter, empty. For this to work, we're going to go into particle spawn. We're going to add skeletal mesh location once again, but this time, instead of sampling triangles, we're going to sample the character's skeletal mesh, and we're going to create zones that get sampled. So skeleton sockets, random under filtered sockets. Since we're using sockets, we're going to add an array element here. We select foot right socket in this particular case. The next one when we duplicate this is going to be left. Sprite renderer, we're going to delete, and we're going to get a ribbon renderer. Select a spawn rate, set it to something like 100, and under initialize particle, we're going to set ribbon width to direct set. This will not show up without moving. So we're forced to press play, and you will see that we have a working trail attached to the character's feet. The lifespan of this is a little bit too much, so under initialize particle, we're going to drop this to a constant number, since having this be random would mess a little bit with how the ribbon fades away. We're going to set this to about 1. Under particle update, we can scale ribbon width over time by using a float from curve. And then over time, this graph will represent the shape that the curve takes. So we're going to press Ctrl A to select all, F to frame it, 1 for weighted tangents, and Ctrl W for user weighted tangents, which allows us to set the distance and the weight of these tangents. Under Ribbon Renderer, we're going to open the default ribbon material by double-clicking on it, and we can just Control-C everything we see here. Create a new material named matte_trail. We will set this one to translucent, unlit, and we will press Ctrl-V to paste everything we just had. We're going to make this more visually interesting by adding a texture to this shader to make it seem as if there is smoke or fire emanating from the character's feet. Usually to combine black and white masks, we would use multiply in this particular way. However, in this case, to make this erode in a more visually satisfying way instead of multiply, we're going to subtract the mask from the texture. This is the wrong way around, so we are going to get rid of the 1- by bypassing it entirely. And we are then going to hold P and press left click to create a panner node for the texture sample, which we will then use to take it in a certain direction. We're going to multiply the emission color by the mask to get a very satisfying dissolve shape with a very nice emission to it. Back in Ephemera, we're now going to drag this new material on top of the default ribbon material. We will then duplicate this, and under skeletal mesh location, we're going to change foot R socket to foot L socket. We're going to press Ctrl-C on the second of these, and we're going to paste this under particle update. And now everything is relatively unified using very few components and creating a lot of visual interest. This is a little bit too noisy, so now we just go back and we tweak until eventually we get what we want. And now at the end of it all, we have a relatively compelling Warframe style ephemera. I hope you enjoyed this very surface level introduction to one of the many ways that a Warframe style ephemera could be made in Unreal Engine. Many of the same techniques would apply in any game engine of your choice. Tag me on Twitter if you make anything with this. That's SPRWTV, Sparrow. I'm allergic to vowels. I'll see you next time. Done. Finished.